All right. Looks like we've got a good mix of people who have joined us so far. So we'll get started. So my name is Alex Webb. I'm the rep and client manager for SENTRY in North America, and I'll be hosting the webinar today. We also have 2 case studies that will be presented by other members of the SENTRY team and our reps to help you understand the application of the technology as well in a little bit more of a concrete way. So first of all, thank you so much for joining us this morning or this afternoon if you're in later time zone. We are really looking forward to this webinar series and being able to showcase all the different ways that SENTRY can help you and your operators do your jobs with a little bit more ease and a little bit more precision and get the outcomes that you're looking for at your facility. Because as a foundation, SENTRY cares about the environment, and we're focused on facilitating better water treatment decision-making for better environmental outcomes. This seems simple enough, but as you know, there are a lot of factors and conditions which make wastewater treatment a challenge. You have upstream challenges such as influent, which are well out of operator control. You have variations in how the biology reacts to what's coming in. You also have sensors, which are not necessarily built for a wastewater environment and must be cleaned or changed regularly, or costly, labor-intensive, and limited manual sampling, which only gives a snapshot of water quality data and often only gives it a few hours or even days later. So today, our webinar is focused on those biological influent events, which are difficult to predict and often even difficult to detect. This can include large slugs of BOD or toxic compounds, which limit the biological treatment capacity. Trying to anticipate and mitigate these events with traditional tools means constant over-aeration to be treating for a peak load all the time because you don't really know when it's going to come through. Or it could mean missing an event entirely with a sample which comes back too late or a sensor placed well after the active treatment process. A more effective tool would be a sensor which could be put up front of the plant with real-time data, letting you know what's coming in and when. So we have a quick poll just to get an idea of what kinds of shocks that you're seeing at your facility. So if Selena, if you want to put up poll 1.
Sure.
Thanks. So if you're seeing biological imbalances related to influent or varying influent conditions, what kind of events have you had that's resulted in treatment issues? So if it's toxic, organic loading, rain dilution, or first flush events, or if you're unsure. So we'll give everybody.
Yeah, the poll will end in 10 seconds.
Oh, perfect. Oh, I'm not allowed to vote.
Okay, I'm sharing the results.
All right, so it looks like we've got quite a bit of toxic and quite a bit of organic loading, which is great. Also some rain events, which can actually have a pretty surprising impact on a treatment plant. And then also unsure. And those are also going to be addressed today just because being a little bit more sure about what those events are that are causing your biological imbalances is really one of the main advantages of the SENTRY. All right. So now that we've discussed the specific problem statement, let's talk a little bit about what is a SENTRY system. So SENTRY is a low maintenance biofilm sensor. It's a simple probe consisting of 2 electrodes. Biofilm grows on the surface of the anode. And as the wastewater loading, the organic loading or toxic loading, as the case may be, flows over the sensor, the biofilm is going to be consuming the carbon. And as it does that, it respires or releases electrons. Those get counted by the sensor and they get stored as data or activity. So this means that the same biofouling that makes other sensors fail in an upstream wastewater application is exactly what makes the SENTRY sensor work. It also means that the activity that you're seeing is a much more accurate picture of how your biology, your treatment biology, will react to that incoming load. It consists of a panel and the probes, and the system is designed to be in a wastewater environment and not just a lab. So it's robust and it's very easy to install. It can also be installed in a variety of different locations in the plant, depending on what problems you're trying to solve. So as you can see, we have different installation methods, and that's something that's going to be unique to your facility layout and the problem statement that you're trying to solve. It can be throughout the plant, and we'll talk a little bit about a little bit later about how where the probe is going to give you a different set of information and going to be able to pinpoint exactly what it is you're seeing at that location in the plant. Once the sensor is installed, the system will immediately begin sending minute-by-minute data, which can be tracked using our cloud-based dashboard, or it could also be connected directly into your SCADA system to be monitored that way. The tech is tried and true, and we have nearly 100 global installations, many that are in water treatment plants, just like your facilities, who are facing challenges that you're also facing. So how can this biofilm sensor technology be applied specifically to this problem of biological imbalance? So most importantly, this sensor can go far upstream. Most frequently, we install in the primary clarifier, which gives a representative loading and also is far enough forward that it gives the operators time to react to that loading as it's coming through and make those operational treatment decisions that are going to address exactly what's in the wastewater. In some cases, we can even go as far up as the collection system to monitor specific discharges. If you have an upstream industry or something that you're not really sure where that load is coming from, we can do a little work to detect exactly where and when that loading is occurring. In this particular case, we've had clients save up to $90,000 in maintenance costs for sensors in the collection system compared to their classic UV sensors. So we have another quick poll about your sensors that you're currently using. So Selena, if you wanted to throw that second poll up. So we're curious about the sensors that you're using. Do you have any upstream sensors that you're attempting to use as a feed forward, as a proactive signal? And do you trust the data that they're giving you, or are you constantly having to recalibrate or clean them to have confidence in the data?
Okay. Sorry, I'm having an error. I can put up the poll later.
Oh, sure. So we'll get that input from you in a little bit. But the value of the SENTRY sensor is in response to either high loading or toxic shocks or even rain dilution events. So a lot of those problem statements that you had identified as things you're facing currently. And it's detecting things that the traditional measurements may miss. It's feed forward and it's real time, which allows operators to actually take proactive action to treat the wastewater coming through and to treat it effectively and cost effectively. There's also the added service from the SENTRY team of data analysis, which can not only help identify what is happening, but also when, to better anticipate those future events that are going to be coming through. So to talk for our first case study, we have our guest, Jim Pelton, who's from Pelton Environmental, one of our reps in Ohio and Kentucky. And he's going to talk about a case that we had, we have been installed in for several years now, and talk a little bit about exactly what the problem was and how they were able to use SENTRY to address some of the issues that they are having at the facility. So thank you, Jim, for joining us, and I will hand it over to you.
Yep. Well, thanks for having me. Just want to make sure you guys can hear me. Are we good there? Okay. All right. So Pelton Environmental, as you mentioned, is a rep for the SENTRY probe. When we became the rep, I immediately approached Frankfort, Kentucky, because of my familiarity with the facility and knowing that that we could help them with several issues that they have. They really are kind of a perfect storm for a probe like SENTRY, in that they're a CSO facility, so they have high wet weather events. There is a lot of industry in town, specifically bourbon distilleries. And so they have had incidents of both high BOD, high loading rates. Within the last year or so, they had an event where they ran their belt presses 24/7 for over a month, just trying to keep up with the solids production going on because of the BOD loading. They've also had events where they come in the morning and find their ditches have turned black. So they are due to toxicity issues from the industry in town. So it's a pretty standard Kentucky wastewater facility, catenary bar screen, grit removal, 3 oxidation ditches, as you can see there, 4 clarifiers, sludge holding, the unique, they do ozone and peracetic acid disinfection. So that's kind of unique. But we went ahead and installed 2 probes. The initial intent was to install one in the post bar screen prior to the grit removal, basically in the Influent channel, as shown there in the picture. And then we were hoping that we could use that Influent probe to identify either a biological load or a toxic shock, and then run the second one into that middle oxidation ditch. Upon installation, the guys decided they didn't want to run the cable across that grass field. You can see from the Influent channel to that middle ditch, they have kind of a driveway through there. So between the lawnmower and truck traffic, they didn't want to do that. So we ended up putting it in a RAS pit just south of the Influent station, where the RAS returns to the Influent and mixes with the Influent. I was involved with installing this unit with the operators there. It took us about a half day. Me and 2 operators kind of figuring it out. The reason I wanted to be involved in it is that SENTRY ships these pre-inoculated, so they have a biofilm on them when they arrive. So you do have to refrigerate them upon arrival, but that allows them to be operational essentially immediately. There does take some time to get to steady state to adopt to the biological environment you put them in, whether it's a influent or anaerobic digester. The biofilm adjusts over the next few days or week or so. So within a half day, we got the probes installed. We fire up the dashboard, and kind of like, what are we going to get here? And within a few minutes, you start seeing the little blue dots appearing in your dashboard, and you say, hey, I think we're getting data. The Influent probe, we started seeing good data right away. On the probe we put in the RAS pit, we actually questioned whether the probe was operating properly, because we were getting metabolic results in the single digits, between 1 and 10, where the Influent probe was showing somewhere between 200 and 400. ultimately we decided that we moved the one from the RAS pit into the Influent channel. It almost immediately snapped back to life, showed that it was operating correctly. And then in hindsight, the idea that a RAS pit is pretty low on biological activity kind of makes sense. All your bugs are starving, there's no more nutrients left. So that in hindsight makes a lot of sense to why we weren't seeing very much data in a RAS pit. And we started seeing almost immediately both toxic shocks and the impact of rain. Once we had some trend lines, you start to see the impact of all the different events that Frankfurt was experiencing. And as far as maintaining the units or having to mess with them, almost nothing. We had to do very little. Frankfurt's bar screens are not great. Like I believe they're 3/4 inch, maybe they're 1 inch. So occasionally they were shaking rags or debris off of the probes, but there is no calibration or any other, reagents or anything that need to be changed. The probes reach steady state and you basically leave them alone. So from there, we started getting the data, started seeing some swings, started seeing some wet weather. And meanwhile, SENTRY's running the data collection, and we started to see some strange things in their statistical analysis. We expected to see biological loading and toxic shocks, and therefore the probes responded accordingly. But what we didn't expect to see was this big spike on Wednesdays. There's, as the graph there is showing, we were seeing basically a 12% additional load on Wednesdays, which nobody could expected. And working with Carl, the superintendent over there, he went to his collection guys and started, what are you doing what is going on Wednesdays that you guys are sending to my plant? And because it's a CSO facility, they've been very busy over the last 10 years or so building giant EQ basins all over the city. And Wednesdays were the day that they would start pumping down whatever had collected over the last week. The facility treats those CSO tanks or EQ tanks with bioxide or biocide, I guess I'll say, not necessarily bioxide. So that was having an impact on the biology coming into the plant. And Wednesdays were also the day that the leachate trucks showed up. So this was an unintended benefit. We had no idea that this was an issue, or the facility didn't even know this was an issue until we came and showed them, hey, something weird is happening on Wednesdays. It's carrying into Thursday, and by Friday you're getting back to normal. So by coordination now between the wastewater plant and the collections group, I don't know if they've eliminated, but reduced their biocide into those EQ tanks to help reduce that problem. And I think they've asked the leachate guys to show up on a day different than Wednesday. So as far as what Frankfurt's doing with the probe, they are now able to quantify these events coming in, how long they last, how significant they are, and that sort of thing. They have implemented they bought the pilot probe, the probe that we started, and they're purchasing a second probe to install in the collection system just upstream of the wastewater plant. They're a little secretive about it, but they have a particular industry that they want to monitor. So they're getting into the collection system just downstream of that industry to see what's going on there. And currently we're operating the probe through the cellular device, which is you can log in from your phone and see what's going on, or anywhere you have internet access. But they're in the middle of a SCADA upgrade. They'll be tying this into their SCADA system and using it to make more educated decisions on biological activity in their plant, what they're seeing and what they need to be doing. Ultimately, I believe Frankfurt will add one of these, a probe to their oxidation ditches to then quantify, hey, we have an issue, whether it's toxic shock or high BOD coming into the plant, but then also monitor how long is it persisting in our treatment process. So I think ultimately they'll end up with 3 sets of probes to start making better decisions about how to treat their wastewater.
Fantastic. Thanks, Jim. That was great, super in-depth, and I think probably resonated with a lot of people here. So if you do have any questions for Jim's specific case, you can throw them in the chat or in the Q&A box, and we'll get to them at the end, because I'm sure that there'll be more questions that will relate to both cases.
Yep. Thanks for having me.
Thanks, Jim.
All right. So our next case is Bend, Oregon. So Tim Truax, who is currently a client consultant with SENTRY, he was the manager of the facility for 5 years and has an extensive career in wastewater treatment prior to that. So he is responsible for implementing the SENTRY system in Bend, and is definitely one of our biggest champions of the technology, and we really enjoy working with him. So I'll hand it over to Tim to talk a little bit about what the issue was at Bend that they were looking to address and how they were able to implement the SENTRY system.
Great. Thanks, Alex. If you could put the next slide up.
Sure.
The Bend wastewater facility is a traditional or typical municipal facility. The population connected to the city is about 90,000 people. But because of the industrial component, the population equivalent in that community is about 130,000. And that's the result of approximately 24 breweries that discharge to the sanitary sewer system. We have extreme variation in BOD entering the facility, but didn't always know when facility was getting BOD, because the laboratory staff only analyzed for BOD 3 days a week, which was the permit requirement. And they also analyzed for BOD 3 days, the same 3 days a week, every week, so that incubations did not end on the weekends. The facility had extremely poor settling, sludge volume indices in the high 200s and low 300s, which made it very difficult to manage the biomass in the secondary clarifiers. That resulted in us having to have very short solids retention times in the order of 3 to 4 days. And that compounded the issue of whether we were able to meet our total nitrogen requirement in the permit. Now, the plant is a 4-stage Barden-Faux process. The aeration zone is IFAS, integrated fixed film activated sludge. The permit limitation is 10 milligrams per liter of total nitrogen. The city has an industrial pretreatment program and staff that would sample the breweries, but because of the batch nature of brewing operations, we felt that we were missing a lot of the slug loadings that were discharged into the sanitary sewer system. Next slide, please. We installed the 2 SENTRY sensors, one in the splitter box going to the primary clarifiers, and the other in the effluent launder of one of the primary clarifiers. That was back in May of 2000. And so we were just getting into to the results or the effects of the pandemic at that point. That would be the time of the year that we would start seeing a lot of tourists in town. That didn't happen, and as a result, we had a brewer, a large brewer, that had beer that they could not sell, and so they got a permit or a permission to discharge at least 2 fermenters of beer into the sanitary sewer system, and the SENTRY sensors were able to detect the discharge events as a result of having those sensors installed in those 2 locations. Again, the traditional way of capturing or estimating BOD was not capturing these discharge events because of the sporadic nature of laboratory analyses. And so an online instrument was essential for us to be able to understand what was happening to the plant and to be able to react to that. So a couple of the ways in which the the SENTRY sensor can be used and has been used for the Bend facility is to anticipate mixed liquor suspended solids growth even when those laboratory analyses are not available to us. The facility can hold on to or store temporarily the filtrate and centrate from their dewatering process and return that to the head of the plant during times of low loading and low flow. Other things that are in the works at that location is to change the intermediate mixed liquor recycle return rate so that more nitrates are returned to the front of the anoxic zones during times when slug loads are appearing, are being measured by the SENTRY probes. We also anticipate that we should be able to increase and decrease aeration set points during times of peak loading or low loading. And if you have any questions for me, please include them in the chat. Alex would like to tell you how you can get a SENTRY sensor.
Yeah, I think we'll try one more time, Selena, for our second poll to see if it works. And if not, that's okay.
I'm sorry, still I'm getting the error.
Okay, that's no problem. Essentially, we've gone over our use case, our specific problem statement of biological imbalance and how a SENTRY system works and how it can be deployed to solve issues that are related to that variable, unpredictable loading that can sometimes be quite a mystery using traditional sensor methods or sampling methods. And so the next question to answer is how do you get one? How do you get one for your facility to answer some of those questions for your own operations and your own operators? So SENTRY works with a network of reps across North America, across Europe, Australia, and around the world. So you can reach out to me. I'll put my email back up on the screen at the end, but you can also reach out to some of our rep partners who represent different geographical territories. So if you recognize one of these rep names as someone in your area, you can reach out to them as well and ask them how can you get a pilot to install SENTRY in your facility and start solving some of those issues. So that's what we have for the presentation portion of today. So what I'll do is I'll head back to the lead slide, which has my email and also the website. And I'll open it up to any questions that you may have. So they can be general questions about the technology. They can be specific questions about the two cases. Or if you have your own use case that you want to walk through a hypothetical exercise of how you could use a SENTRY at your own facility, you're also welcome to ask something about that. So again, we have two options. There's the chat function or there's the Q&A function. So I'll give you a few minutes to type furiously while I head back to the initial slide. Oh, nice. I just learned something about how presentations work in PowerPoint.
Alex, Alex,
Yes.
are people able to ask questions or are their microphones muted?
I believe their microphones are muted, but Selena can maybe unmute them.
Yeah.
So if you'd like to ask a question, you can also use the raise hand function. And Selena can unmute you to be able to ask your question. All right. Well, so while you guys sort of percolate on some of the questions you have specific to your facility, I'll throw a couple questions out to Tim and Jim. So, Jim, you had talked a little bit about the installation process and how long it took. So, Tim, if you wanted to maybe talk a little bit also about how it was to install the SENTRY sensors.
Sure. So the sensors arrived via FedEx, I believe. We were not ready to install them at the time that they arrived, still had some preliminary work to do. And so we refrigerated the probes as was required. We mounted the panel and then devised a mounting system using PVC piping and clamps to be able to attach the PVC pipes to structural steel members. I got a lot of good information from SENTRY initially about good locations, ways to secure the probe in the locations. Originally, I had the primary clarifier probe installed in between the scum baffle and the weir of the primary clarifier, but it's found that because of our particular wastewater, solids were accumulating on the probe, and I thought that may be interfering with the signal that was being generated. So we moved that to the effluent launder of the primary clarifier, and because we have extremely low flows during early morning hours, I actually backed up the effluent launder using cinder blocks, which I secured so they didn't end up in my aeration tank. And that additional or that change in location gave a more steady signal for making decisions based on what was entering the aeration tank.
Awesome. Thanks for that answer. I think it talks a lot about the ease of installation of the probe and how to get the best results out of the installation location that you choose. So we have a couple of questions in the Q&A. So we have one question, which I've just asked for a clarification about monitoring toxic shock in the absence of a carbon source. So if Adele, if you could maybe elaborate a little bit more about what location you have in mind that wouldn't have any sort of carbon source at the wastewater treatment plant. And so while you type that out, we have a second question. Oh, sorry, a full nitrification reactor without carbon. Are you dosing ammonia? How are you feeding the nitrification bacteria? So Pat, you can go for it and answer this one, and then we'll go to Peter's question afterwards.
Fantastic, thanks, Alex. So we have two questions, one from Adele. So if it's a nitrification reactor, our biology that grows on these sensors is carbonaceous. So what we can do is we can put sensors before nitrification, so we can put them in primary clarifiers or post-aeration basins and still flag those biological upset events. So we can flag those events in the wastewater to say, look, something is clearly inhibiting biological activity at this part of your process. Be aware, because it's going to also impact downstream processes. So that's what we're very good at, is when there is carbon in the wastewater, flagging those massive changes or those significant events so that you can be aware of it for downstream.
So I'm not
So
sure if you saw the follow-up.
Yeah, in terms of the strain of bacteria, Geobacter as a species, typically, it's a smaller percentage than you might think. It's a heterotrophic mixed culture biofilm that grows on there. So it's really resilient, really robust, but it's a mixed culture biofilm. And then Peter asks, how does SENTRY tech differ from ATP biological monitoring? Thank you, Peter. ATP monitoring, it's very similar in terms of functionality, in terms of the actual data. The problem with ATP monitoring is you physically have to go and take a sample, do an analysis, and then you get one data point. So there's a lot of effort and there's a lot of resources required to get that data. So ours is basically an always on measure that is analogous to and similar to an ATP reading. So what we like to think is you put our sensors in the wastewater streams, we can flag those key events for operators and then have operators go and take or do wastewater sample analysis based on those alarms. Because if you're just doing regular water quality analysis or wastewater analysis Monday to Friday at 9 o'clock, it's not helping anyone. So we can help you actually, alert you to those events and then allow you to sample your wastewater. So maybe you want to do an ATP analysis, but let us tell you when to do it when there's actually an event taking place.
That leads into Jay had a question in the chat about how we use the alarm investigation action structure to train our team, and how do we know when to take action?
Fantastic. I could answer that, or maybe Tim as well. Tim, you might be better qualified from an operations standpoint. I'll take a first crack at that.
Sure.
So Jay, from our perspective, data/information that we provide is interesting and valuable. But really what's most important is that our operators have clear, actionable steps to take based on those alarms. So for example, if it's a high-end alarm that we're flagging at the influent of a plant, it's typically indicative of significant organic overloading coming into your facility. So we have those SOP guides now defined. So operators, once they get that alarm, there's a couple of questions they'll ask themselves based on the SOP, and then it will feed them into suggested action items that they can take to minimize the impact of these events downstream, i.e. on effluent quality. In a similar way, if it's a low-end alarm, it's indicative of 1 or 2 or 3 different things in the process. Is there something toxic in the wastewater? Is there heavy rain infiltration? And again, all of these events that we can flag in these primary clarifier locations, they're always indicative of eventual effluent issues, whether it's effluent BOD or whether it's effluent on the nutrient side. So what we want to do is give our operators that early warning to say, we can flag these events right up forward in your plant. And then you can, with that warning and with that time that you then have, we can then provide you those actionable tasks in that SOP guide to say, okay, it's a low-end alarm. Based on these 2 questions, we're pretty confident it's this. Now let's go and implement some sort of on-site decision to minimize the impact of that, whether it's recirculation rates, whether it's MLSS, whatever we can do at a facility to minimize the impact. We have that chance now to do that. Tim.
A great answer, Pat. I think that those are the approaches that we always want to take. As far as setting the alarms themselves, we think that a collaborative approach is the most effective, because you don't want to get alarms for events that you can identify as normal operations in your facility, whether it's a returning whether it's returning a high strength side stream flow, or a dewatering process, or some other knowable anticipated event. We don't want to have alarms, because the last thing we want to do is have operators ignore the alarms that have been set.
And just to add on to that a little bit, so one of the very interesting things about having so many deployments is that we can see very different patterns that become a kind of a fingerprint of wastewater profile that are unique to your facility or your your deployment. And as Tim mentioned, being able to work with the team that's going to be taking action to recognize what that pattern is and what the outcome is going to be, whether you do or do not take certain actions, is really what that training and that collaborative process is about with the SENTRY deployment. So thank you for your question, Jay. We have another question from John Glockner. What is the life cycle of the probe? So I'm guessing you mean the durability. How long does it last? So I will turn this one over to Pat to answer.
I'll take that first, and then maybe Tim, you can join in on that too. So we've been deploying commercial systems now for nearly 4 years. Our longest commercial deployments are over 3 years. This is why I think we have something that's very unique and disruptive in the industry. Everyone knows in the industry that if you have a light-based sensor, you better not put it far forward in your process, because you'll be cleaning it every hour if you want to get a reliable signal. So sensor drift is the plague of good data in wastewater environments. So our technology is simple. We want biofilm on that surface. We don't want people typically cleaning the biofilm or doing anything to it. So it's fit for purpose in a wastewater environment. There's no moving parts. There's no on-site calibration of the equipment. Once you receive it, all of that is done on the dashboard, or any of it that has to be done is done on the dashboard. So conservatively, we say 6 to 7 years as the lifespan of the product, but in reality, I think 10 years would be more appropriate for this type of technology in a wastewater environment.
And maybe Tim and Jim could each sort of speak to their impression about how durable and robust the sensors and the panel really are in situ.
Sure. So the two installations that we had in Bend in the primary clarifier Influent splitter box and in the effluent launder, those probes have not required any maintenance at all, not even cleaning. We pull them out of the water periodically every 3 to 6 months just to verify that we don't have any rags or other debris accumulating on the sensor, which would normally be flagged by the dashboard, but have seen no fouling of the sensor at all that is of any concern.
And my experience is very similar. In the Influent channel, we've not had to do anything other than shake rags off, and that's more of a concern of ripping the sensor out of the channel. If you get too much velocity, so almost no cleaning. I actually pulled up Frankfurt's dashboard here on my side, trying to see exactly when we installed that thing. I know it's been at least 6 or 8 months, and we have not messed with it at all. So that's the extent of my experience is that on a day-to-day basis, there's almost nothing, and I'd have to defer to Pat, on how long it's going to last entirely.
Great, thank you both.
I would add to that as well, Alex. We do offer the equipment both as a service and as a capital purchase. So if a sensor is purchased under the service agreement, if anything ever happens, we replace it at no cost. So we do try and de-risk all of those aspects for our clients.
Mm-hmm. Yeah, and I mean, if you're interested in seeing how the sensor would perform in your specific facility, that's why we've developed the pilot program to deploy the sensor for a 4-month period, which allows for enough data to get some valuable insights, but also really see how the sensor is going to perform long term. All right. Well, so we have about 4 more minutes for questions. If anyone has any questions, you can either raise your hand using the raise hand function, or you can type it into the Q&A or the chat. It looks like we've got all the ones in the Q&A and the chat have been answered so far. So, So I guess if we don't have another question, I have one more question for Jim and Tim about their facility or their pre-SENTRY facility, which is what were some of the, Tim kind of talked a little bit about some of the limitations to the sampling that his facility was experiencing, but maybe Jim, if you know what Frankfurt was doing in terms of sampling, that obviously was letting a few things through the gaps to not be aware of the large events on Wednesdays, but what kind of sampling protocols did they have?
They continue to do their standard grab samples on BOD, COD, and we've actually charted our results against their grab samples. So they were doing just a standard water and wastewater sampling for process control and compliance, but they were not doing anything proactively. I mean, they were entirely reactionary to these various, they know when it's raining, right? I mean, so they know when the wet weather is going to show up. But as far as BOD slugs or toxicity events, it was completely reactionary and have to deal with it as it came and just guess how long it's going to last. This incident where they're running their belt press for a month straight to keep up with their solids they just do, like a lot of wastewater operators, they're really good at making it work, but they're not getting any advanced information as far as what's going on or how long it's going to last or any of that kind of stuff. So this is kind of their first foray into having some feed forward information to make better or different decisions.
Fantastic. Thanks. Tim, did you have anything to add to that?
No, I really don't. The online aspect of SENTRY is, I think, is a game changer for plant operations. Instead of finding out 5 days later what came into your plant, on a minute-by-minute basis. Peter asked a question: does the tech measure only dissolved carbonates?
All right, I think this is a Pat question.
Agreed.
Okay, so it's more specific. So yes, the biofilm that grows on these surfaces is mixed culture, heterotrophic, carbonaceous. So it is only consuming carbon, bioavailable carbon, BOD, as its substrate. But why that's powerful and why is we're measuring the rate at which the biofilm in your plant are consuming food. That's the primary job that all this biomass has to do. So from an operational perspective, what we want to do is flag those events and quantify for our operators how significant they are. If the wastewater coming into your plant is repressing or making your biomass work much harder, either way, you need to know about that, because that's going to impact all of your downstream processes. So just because we have this mixed culture carbonaceous biofilm does not mean that it's not indicative of other communities in your downstream processes. We're like that first line of defense, really simple, really easy to use, low maintenance, and we're going to help you get that early warning for all your downstream reactors also.
All right. Well, I'll leave 10 more seconds. If we don't have any more questions, I will wrap up our presentation and give you guys a few minutes back into your day to grab a coffee or something like that. So again, thank you so much for joining us today. I think we've had a really interesting discussion and two really great cases that showcase how this SENTRY sensor technology can be used specifically for the biological imbalance problem statement. If you've signed up for this webinar, you probably also know we have other upcoming webinars next Thursday, the one after, and then October 7th, which will be looking at how to use the SENTRY technology to address other problems that wastewater operators or anaerobic digestion operators face when they're trying to operate their treatment plants effectively and stay in compliance with all of the different requirements that they have for their effluent, but also save costs, save labor, and just be efficient and effective when they're operating the plants. So if you're interested in the other problem statements we have, which is optimization, so beyond just early warning, but actually planning out actions to have better outcomes and lower costs from your wastewater treatment plant, that's next week. And then the following week, we have an anaerobic digester specific applications. So again, we'll go over the technology. We'll talk about a few cases where we've installed and deployed the SENTRY systems and what some of their outcomes have been. And then we also have our top 5 webinar, which will be talking about our favorite deployments from the past year and some of the really interesting things that we've been able to find out and take action on at different facilities around the world. So we really look forward to seeing you at those next ones. And thank you again. Have a really great end of your week.
Thanks
And,
everyone for joining.
Thank you so much to our panelists for
Thank you.
their contributions.
Thank you. Bye,
Talk
Alex.
soon.
Bye, Pat.
Bye, everyone.
Thanks, everybody.